So now we want to look at inequalities and how we go about solving inequalities. So an inequality is a statement that consists of any one of the following: less than or equal to, greater than or equal to. So in essence, we all know that the equation, so say for example, an equation or equality would be a statement with an equal sign. So 2x plus 1 equal to 7, we would call that an equation, simply because the equal sign there. But let's say we have something like 2x plus 1. And let's say we put any one of these four symbols here. Then what we have is an inequality. So if we put the less than 7, then that's an inequality. Or if we put the greater than 7, then that's an inequality. Or if we should put greater than or equal to, then that's an inequality. So there's a difference between the two type of problems. So this is an equation, and what we have below, any one of these four symbols in this statement, we consider that to be an inequality. In prefix mean not, so it's not an equality. Alright? Now, the approach to solving these type of problems is no different from solving equations. Except, and notice I have except there in bold, just one major difference. And that's when we are multiplying or dividing both sides of the inequality by a negative number. Now, before we get into solving problems, consider this. So, if I have something like negative 5, and I have, say I have 2 over here, or 3 over there. Which sign would you put there? Yes, negative 5 is actually less than 3. Conventionally, we normally read from left to right. That's how a normal person read it. Negative 5 from less to 3. Negative 5 is less than 3. But of course, you can read it from right to left. 3 is greater than negative 5. Same as I could say, Paul is taller than John. Or reading from right, you could say John is shorter than Paul. You see, in effect, you're saying this the exact same statement. Alright? You're saying an equivalent statement, that is. But the same idea. So negative 5 less than 3, or we say 3 is greater than negative 5. But let's read from left to right. So negative 5 is less than positive 3. Now, what if I should multiply both sides of that inequality by any negative number? Let me use negative 2. Any negative number. It doesn't matter which negative number. Let me use negative 2. If I multiply both sides by negative 2, I would have negative 2 times negative 5. Negative times negative is positive. And then I would have negative 2 times positive 3. And negative times positive, that's negative 6. Now, what if we still put a less than sign there? Look, what is this statement saying? This statement is saying 10 is less than minus 6. Now, does that make sense? It definitely does not make any sense. For the statement to make sense, then you have to turn around the symbol, and the less than symbol will become now a greater than. Right? Now let me just put this back again. Minus 5 is less than 3. What if I should times both sides down by a positive 2? So positive 2 times minus 5, that's minus 10. And positive 2 times 3 there, that's 6. And this statement is actually true. This is saying negative 10 is less than 6. So notice that when you multiply both sides of the inequality by a negative number, for the new statement to make sense, the symbol here have to change direction. And when you multiply both sides by a positive number, we did not need to change direction for the statement to make sense. Because here, we're saying negative 10 is actually less than 6. Let's check it with division. Let's say we have minus 6 is less than 12. Is minus 6 less than 12? Yes, it is. And let's say we should divide both sides of this inequality by negative 3. Let's say we divide both sides by negative 3. So what's minus 6 divided by minus 3? Divide both sides by 3. Both sides divided by 3, right? Minus 6 divided by minus 3, that's what? Positive 2. Remember, negative divided by negative is positive. And 12 divided by minus 3, you're dividing, and the signs are different, one positive, one negative. So just like with multiplication, you end up with a negative result. So minus 4. Now, do we still keep this less than symbol there? No. Is 2 less than negative 4? Absolutely not. And as a result, for this statement to make sense, we have to change direction of the symbol there. On the other hand, 2 actually is greater than minus 4. So that would make sense. Let's say we have the same statement. Negative 6 is less than 12. And let's say we're dividing both sides by positive 3 this time. Alright, so dividing both sides by positive 3. Divide the 12 also by positive 3. What's negative 6 divided by positive 3? Yes, you're dividing, so signs are different, so the result is negative. And 12 divided by 3, that's what, 4? So is negative 2 less than 4? Yes, it is true. So notice, when you're dividing by a positive number, just like when you're multiplying by a positive number, no need to trouble the symbol here. But the result we get actually makes sense. But once you choose to multiply by a negative number, or divide both sides by a negative number, for your new statement to make sense, then the direction has to change. And that is a principle we use when solving inequalities. Let's look at a problem. So here's the first problem we want to look at. Now, as I said earlier, we go about solving these equations the same way we solve an equation, right? You want to group like terms and isolate the x. Good? And how can we do that? Notice we have negative 1. So what we need to do now? We need to add 1 to both sides. Alright, so we have minus 2x, and then it's negative 1 disappear. So now we have 13 plus 1. Or if you want to say negative 1, now it's positive 1. Alright? So we have minus 2x less than or equal to 13 plus 1, 14. And now we want to get rid of the minus 2. Just like solving an equation, it's all about isolating the x, getting the x by itself. So you need to get rid of this negative 2, and hence we divide both sides by negative 2. So negative 2 divided by negative 2, we end up with just x, because negative 2 upon negative 2, that's positive 1, right? So positive 1x. Anything divided by itself is 1. But careful now, remember what we just discussed? Once you're dividing both sides of the inequality by a negative number, then the inequality has to change direction for your solution to make sense. So our solution is x is greater than or equal to negative 7. And sometimes you're asked to show this on a number line. X is greater than, let me just use a number line quickly. So let's say this is 0, and the number line continues, this is 1, 2, and so on, it continues. Here we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So if we show this in a number line, Because R equal to is there, then we use what we call a full dot. And greater than we move to the right of the number line, right? So it's R there to show that. Greater than minus 7 goes on and on from negative 7, greater than or equal to. So the full dot signifies that x can be equal to negative 7. Alright, if you talk about a solution set of say of integers, then it would be minus 7 included, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. Alright, let's look at another problem.